What if I told you that one simple 4-step cycle has helped some of the world's leading manufacturers improve quality, reduce defects, and boost productivity for decades? Hello, everyone, and welcome to the Factory Insights, your go-to channel for manufacturing, quality, engineering, and continuous improvement. In manufacturing and quality management, there's one concept you'll hear again and again: the PDCA cycle. Many engineers think PDCA is simply a problem-solving tool, but that's only part of the story. In reality, the PDCA cycle is the foundation of continuous improvement, process control, and quality management systems, such as ISO 9001 and IATF 16949. Whether you're a quality engineer, production engineer, manufacturing professional, supervisor, or a student preparing for a career in manufacturing, understanding PDCA is essential. In this video, we'll break down each stage of the PDCA cycle using practical manufacturing examples, so by the end, you'll know exactly how to apply it in your workplace. So, let's get started. Imagine walking into a factory where defects are increasing, customer deliveries are delayed, and production processes are no longer under control. Teams are working hard to fix one problem after another, but the same issues keep coming back. Why does this happen? Because solving problems without a structured approach rarely creates lasting improvement. That's exactly why leading manufacturers around the world use the PDCA cycle. Many engineers think PDCA is just a problem-solving method. In reality, it's the foundation of continuous improvement and quality management systems, such as ISO 9001 and IATF 14949. So what does PDCA stand for? PDCA stands for Plan, Do, Check, and Act. It follows a simple but powerful sequence. First, plan what needs to be improved. Next, do by implementing the plan on a controlled scale. Then, check the results by comparing them with your expected outcomes. Finally, act. If the change is successful, standardize it and make it part of your regular process. If the results aren't satisfactory, learn from the findings, make the necessary adjustments, and repeat the PDCA cycle. This continuous loop helps organizations improve step by step instead of relying on one-time fixes. The PDCA cycle is also known as the Deming cycle, named after the renowned quality expert Dr. W. Edwards Deming, who played a major role in popularizing this approach worldwide. Today, PDCA is one of the fundamental principles behind lean manufacturing, Six Sigma, ISO 9001, and IATF 16949, helping organizations improve their processes in a systematic and continuous way. Many people think PDCA is only used when something goes wrong, but that's a common misconception. In reality, PDCA is the backbone of modern quality management systems. Global standards like ISO 9001 and IATF 16949 are based on the same continuous improvement approach. Whether you're conducting an audit, improving a manufacturing process, managing risks, or developing a new product, you'll find the PDCA cycle at the core of the process. Take APQP, for example. Every phase of advanced product quality planning follows the PDCA methodology to ensure quality is built into the product from concept to production. That's why PDCA isn't just a tool, it's a mindset that drives operational excellence. Every successful improvement begins with a solid plan. That's exactly what the plan stage is all about. Before implementing any changes, engineers first understand the process, define clear objectives, identify potential risks, and create a structured improvement plan. Rather than waiting for problems to occur, the focus is on preventing them before production even begins. Teams review historical defect data, customer feedback, process performance, and previous quality issues to identify the root causes of recurring problems. Once the causes are understood, they define the necessary process controls to eliminate or reduce those risks. This stage typically involves quality planning tools such as process flow diagrams, failure mode and effects analysis, risk assessment, historical defect analysis. A strong plan lays the foundation for a stable process and consistent product quality. Now let's see how the plan phase fits into APQP, Advanced Product Quality Planning. In the automotive industry, APQP is the standard framework used to ensure quality is built into a product from the very beginning. Interestingly, the first two phases of APQP closely align with the plan stage of the PDCA cycle. Phase 1 is Plan and Define Program. During this phase, teams gather customer requirements, define project objectives, establish timelines, and perform an initial risk assessment. The goal is simple: ensure the project has a clear direction before any design or manufacturing activities begin. Phase 2 is Product Design and Development. Here, engineers develop the product design, evaluate technical. Now let's see how the plan phase fits into APQP, Advanced Product Quality Planning. In the automotive industry, APQP is the standard framework used to ensure quality is built into a product from the very beginning. Interestingly, the first two phases of APQP closely align with the plan stage of the PDCA cycle. Phase 1 is Plan and Define Program. Now let's look at how the plan phase of the PDCA cycle relates to the 8D problem-solving methodology. The primary objective of the plan phase is to clearly understand the problem and develop a structured plan before taking corrective action. Interestingly, when you compare PDCA with 8D problem-solving, you'll find that the plan phase closely aligns with the early stages of the 8D process. In D1, a cross-functional team is established to investigate the issue from different perspectives and bring together the right expertise. In D2, the problem is clearly defined using facts, data, and evidence, ensuring everyone has the same understanding of the issue. These first two disciplines serve Now let's look at how the plan phase of the PDCA cycle relates to the 8D problem-solving methodology. The primary objective of the plan phase is to clearly understand the problem and develop a structured plan before taking corrective action. Interestingly, when you compare PDCA with 8D problem-solving, you'll find that the plan phase closely aligns with the early stages of the 8D process. In D1, a cross-functional team is established to investigate the issues to the 8D problem-solving methodology. The PDCA cycle doesn't stop at problem-solving. In fact, it forms the foundation of modern quality management systems. Standards such as ISO 9001 and IATF 16949 are built around the same continuous improvement philosophy. Their requirements encourage organizations to plan their processes, implement them effectively, monitor and measure performance, and take action to continually improve results. This structured approach helps organizations improve quality, reduce risk, increase customer satisfaction, and achieve operational excellence. That's why the PDCA cycle isn't just a quality tool, it's the management framework behind world-class manufacturing. Now that we've explored the plan phase, let's move on to the second stage of the PDCA cycle, do, where planning is transformed into action through controlled implementation. A great plan has little value unless it's put into action. That's exactly what the do stage is all about. During this phase, the improvement plan is implemented in a controlled environment. Instead of making immediate plant-wide changes, manufacturers usually start with a pilot run, trial production, or a limited-scale implementation. This approach allows engineers to observe how the process performs under real operating conditions without exposing the entire production system to unnecessary risk. The team collects data, monitors process performance, identifies unexpected issues, and verifies whether the planned improvements achieve the desired results. In simple terms, the do phase transforms planning into practical action while keeping risks under control. The do phase of the PDCA cycle is where planning is transformed into execution. During this stage, the activities defined in the plan phase are put into practice through controlled implementation. Now, let's see how this stage connects with APQP. Within the Advanced Product Quality Planning (APQP) framework, the do phase of PDCA aligns primarily with Phase 3, Process Design and Development. This is the stage where the manufacturing process is designed and the production system is developed to support consistent, high-quality manufacturing. Engineers define the process flow, identify process risks, establish quality controls, and prepare the documentation needed for production. Typical deliverables in this phase include Process Flow Diagram, PFD, Process Failure Mode and Effects Analysis, PFMEA, Control Plan, Standard Work Instructions. Together, these tools help ensure that the manufacturing process is capable, repeatable, and ready before full-scale production begins. In simple terms, APQP Phase 3 transforms product planning into a production-ready manufacturing process.
That's why the primary objective of the do phase is to implement the planned activities, validate the manufacturing process, and prepare the organization for successful production. Now that we've seen how the do phase aligns with APQP Phase 3, let's explore another important connection. How does the do phase of the PDCA cycle relate to the 8D problem-solving methodology?
Now let's see how the do phase of the PDCA cycle connects with the 8D problem-solving methodology. The do phase follows the planning stage, where investigation begins and the planned activities are put into action. During this stage, the team works to identify the root cause of the problem and develop effective solutions. When we compare PDCA with 8D problem solving, the do phase aligns most closely with D4 and D5. In D4, root cause analysis, the team investigates the problem using proven quality tools such as 5 Whys, Fishbone, Ishikawa diagram, and data analysis to identify the true cause of the issue. Once the root cause has been confirmed, the process moves to D5, develop and verify permanent corrective actions. During this step, the team develops, evaluates, and selects corrective actions that will eliminate the verified root cause and prevent the problem from recurring. In simple terms, the do phase is where investigation is transformed into action. It's the stage where organizations identify the real cause of a problem and develop effective corrective actions to achieve lasting improvement. If you'd like to learn the complete 8D problem-solving methodology with a real manufacturing case study, be sure to watch our dedicated 8D video here on the Factory Insights. We'll walk you through all 8 disciplines step by step using a practical industry example. We've connected the do phase with APQP. We've connected it with 8D. Now it's time to connect it with the framework that governs the entire organization, its quality management system. Let's discover how the do phase is reflected in ISO 9001 and IATF 16949. Understanding these connections helps you see that PDCA isn't just a problem-solving tool. It's the common language behind modern manufacturing and quality management. Now let's explore how the do phase of the PDCA cycle connects with the IATF 16949 quality management system. The do phase is where planning is transformed into execution. During this stage, organizations implement the processes they have planned and ensure that the necessary resources, infrastructure, and controls are in place for successful execution. When we compare the PDCA cycle with IATF 16949, the do phase aligns primarily with Clause 7, Support, and Clause 8, Operation. Clause 7, Support, ensures that the organization has the resources, competent people, infrastructure, organizational knowledge, and documented information needed to operate its processes effectively. Once these elements are in place, Clause 8, Operation, focuses on executing the organization's operational processes. This includes product realization, production planning and control, manufacturing operations, process management, and customer-specific requirements, ensuring that products are consistently produced according to defined specifications. In simple terms, the do phase is all about executing what was planned. And that's exactly what IATF 16949 Clauses 7 and 8 are designed to achieve, providing the support, resources, and operational controls needed to deliver consistent product quality. Now that the process has been implemented, the next step is to answer an important question. Is the process actually performing as expected? This brings us to the third stage of the PDCA cycle, check. During the check phase, engineers evaluate the results by collecting and analyzing process data. The objective is to verify whether the process is stable, capable, and consistently meeting the planned quality objectives. To do this, organizations use quality tools, such as inspection reports, statistical process control charts, or SP charts, and process capability studies, like CP and CPK. These tools help determine whether the process is operating within control limits and consistently producing products that meet customer requirements. If the results meet expectations, the process is ready for standardization and continuous monitoring. If not, the gaps are analyzed, corrective actions are identified, and the improvement cycle continues. In simple terms, the check phase is all about measuring performance, validating results, and making data-driven decisions before moving to the next step. Now let's see how the check phase of the PDCA cycle connects with APQP, Advanced Product Quality Planning. The check phase is all about verifying whether the planned activities and implemented processes are delivering the expected results. During this stage,
engineers evaluate both process performance and product quality to confirm that the manufacturing process is meeting its planned objectives. When we compare the PDCA cycle with APQP, the check phase aligns primarily with Phase 4, product and process validation. This phase is designed to verify that the manufacturing process can consistently produce products that meet customer requirements and quality expectations. Typical validation activities include trial production runs, process capability studies, CP and CPK, product inspection and testing, measurement system analysis, or MSA, to verify the accuracy and reliability of the measurement system. Another major deliverable of this phase is the PPAP, Production Part Approval Process. Through the PPAP submission, the organization demonstrates to the customer that both the product and the manufacturing process are capable, stable, and ready for full-scale production. In simple terms, the check phase is the validation stage of the PDCA cycle. It confirms that the product and the manufacturing process consistently meet the planned requirements before moving to full production and standardization.
We've seen how the check phase aligns with APQP and validates both the product and the manufacturing process. But that's not the only place where this verification mindset appears. The same principles are also reflected in the 8D problem-solving methodology. Now let's see how the check phase of the PDCA cycle connects with the 8D problem-solving methodology. The check phase is where organizations verify whether the implemented corrective actions are actually delivering the desired results. During this stage, the focus is on monitoring performance, analyzing data, and evaluating the effectiveness of the corrective actions. When we compare the PDCA cycle with 8D problem-solving, the check phase aligns primarily with D6, implement and validate permanent corrective actions. In D6, the organization verifies that the corrective actions have successfully eliminated the root cause and that the problem has not recurred. Engineers review process performance, analyze production data, monitor quality metrics, and conduct verification activities to confirm that the implemented solution is both effective and sustainable. The goal is not simply to confirm that the problem has disappeared, but to ensure that the manufacturing process is stable, capable, and consistently delivering the expected results. In simple terms, both the PDCA check phase and 8D D6 share the same objective, verifying that the corrective actions are effective and that the problem has been permanently resolved. So far, we've seen how the check phase connects with APQP and the 8D problem-solving methodology. Now let's explore how it fits into the IATF 16949 quality management system. The check phase is all about monitoring, measuring, and evaluating process performance to determine whether the planned objectives have been achieved. When we compare the PDCA cycle with IATF 16949, the check phase aligns primarily with Clause 9, Performance Evaluation. Clause 9 requires organizations to regularly monitor, measure, analyze, and evaluate the effectiveness of their processes and the overall quality management system. Typical activities within this clause include process performance monitoring, product inspection and testing, internal audits, management review. These activities help verify that processes are operating as planned, customer requirements are being met, and the organization's quality objectives are being achieved. They also provide valuable data for identifying risks, measuring performance trends, and uncovering opportunities for continual improvement. In simple terms, both the PDCA check phase and IATF 16949 Clause 9 share the same objective: evaluating system performance, verifying process effectiveness, and identifying opportunities to improve. Once we've verified that the improvements are delivering the expected results, the next step is to make those improvements a permanent part of the process. This brings us to the fourth and final stage of the PDCA cycle: ACT. During this stage, successful changes are standardized, best practices are documented,
and the improvements are rolled out across the organization. The goal isn't just to solve today's problem, it's to prevent it from happening again and create a foundation for continual improvement.
Now let's see how the ACT phase of the PDCA cycle connects with APQP, Advanced Product Quality Planning. The ACT phase is where organizations take the results of implemented improvements and turn them into long-term, sustainable practices. The primary objective of this stage is to standardize successful changes, capture organizational learning, and use that knowledge to drive future improvements. When we compare the PDCA cycle with APQP, the ACT phase aligns primarily with Phase 5, feedback, assessment, and corrective action. During this phase, organizations analyze production performance, customer feedback, field data, and quality trends to identify additional opportunities for improvement. Based on this information, teams implement further corrective actions, optimize manufacturing processes, and document lessons learned to strengthen future product development projects. These lessons are then shared across the organization to improve planning, reduce risk, and prevent similar issues in future programs. In simple terms, the ACT phase is the engine of continual improvement. It ensures that the knowledge gained from one project is captured, standardized, and applied to future products and manufacturing processes, making the organization stronger with every improvement cycle. Now let's see how the ACT phase of the PDCA cycle connects with the 8D problem-solving methodology. The ACT phase is where successful corrective actions are standardized and the organization takes steps to prevent the problem from recurring. The focus of this stage is to strengthen the management system by embedding the improvements into everyday operations and capturing valuable organizational learning. When we compare the PDCA cycle with 8D problem solving, the ACT phase aligns primarily with D7, prevent recurrence, and D8, congratulate the team. In D7, organizations update their procedures, work instructions, control plans, FMEAs, and other management system documents to ensure that the same problem does not occur again. These updates transform successful corrective actions into standardized practices across the organization. In D8, the team recognizes the contributions of everyone involved, celebrates the successful resolution of the problem, and documents the lessons learned. Sharing this knowledge helps future projects avoid similar issues and strengthens the organization's culture of continuous improvement. In simple terms, both the PDCA ACT phase and the final stages of 8D have the same objective: standardizing successful improvements, updating management system controls, sharing organizational knowledge, and building a culture of continual improvement. The principles of the ACT phase extend beyond 8D problem solving. Let's now explore how this final stage of the PDCA cycle is reflected in the IATF 16949 quality management system and how it supports continual improvement across the entire organization. The ACT phase is where organizations take action based on the results of performance evaluation and use those findings to drive continual improvement. The primary objective of this stage is to implement effective corrective actions, eliminate the root causes of problems, and strengthen processes to achieve better performance in the future. When we compare the PDCA cycle with IATF 16949, the ACT phase aligns primarily with Clause 10, improvement. Clause 10 requires organizations to respond to nonconformities, implement corrective actions, eliminate the underlying causes of problems, and prevent similar issues from occurring again. It also promotes continual improvement by encouraging organizations to enhance the effectiveness of their quality management system, improve process performance, and increase customer satisfaction. Typical activities within this clause include corrective action, root cause elimination, problem solving, continual improvement initiatives, updating the quality management system based on lessons learned. In simple terms, both the PDCA ACT phase and IATF 16949 Clause 10 share the same objective:
continually improving the management system, strengthening organizational processes, and driving better business performance over time. And once these improvements are standardized, the cycle begins again with a new plan, making PDCA a continuous journey rather than a one-time activity.
Let's understand the PDCA cycle with a real manufacturing example. Imagine you're working in an automotive injection molding plant. Suddenly, the rejection rate for a plastic component increases because of short shots. The customer has started raising complaints, production efficiency is dropping, and scrap costs are increasing. How can the PDCA cycle help solve this problem? Let's go through each stage. During the plan phase, the quality and production teams first define the problem. They analyze rejection data, review production records, and identify where and when the defects are occurring. The team performs root cause analysis using tools such as the 5 whys, fishbone diagram, and Pareto analysis. After the investigation, they discover that inconsistent mold temperature is causing incomplete filling, which leads to short shot defects. Based on this finding, the team prepares an action plan to optimize mold temperature and improve process consistency. In the do phase, the planned actions are implemented on a pilot production run. Engineers adjust the mold temperature settings, update the machine parameters, and provide instructions to machine operators. Production continues under controlled conditions, while all process changes are carefully documented. During the check phase, the team evaluates the results. They compare the new rejection rate with previous production data. They also review SPC charts, inspect finished parts, and perform process capability studies to confirm that the process is stable. The results show that the short shot defects have decreased significantly, and the process is consistently meeting customer specifications. Since the improvement has been proven effective, the organization moves to the act phase. The new mold temperature settings are standardized by updating the control plan, work instructions, and process FMEA. Operators receive additional training, and the lessons learned are shared with other production lines to prevent similar issues in the future. The improvement becomes the new standard, and the organization is now ready to begin the next PDCA cycle for further optimization. This example shows why the PDCA cycle is much more than a problem-solving tool. It's a systematic approach for identifying problems, implementing solutions, verifying results, and continuously improving manufacturing processes. That's exactly why PDCA is the foundation of world-class manufacturing systems, including ISO 9000, IATF 16949, APQP, Lean Manufacturing, and Six Sigma. And that's the complete PDCA cycle, from planning and implementation to verification and continual improvement. As you've seen, PDCA is much more than a problem-solving tool. It's the foundation of world-class manufacturing, quality management systems, lean manufacturing, Six Sigma, APQP, and IATF 16949. If you found this video helpful, don't forget to give it a thumbs up and subscribe to the Factory Insights for more practical videos on manufacturing, quality, engineering, and continuous improvement. If you have any questions or topics you'd like us to cover next, let us know in the comments below. We'd love to hear from you. Want to see how PDCA is applied in real-world problem-solving? Watch our complete 8D problem-solving case study next, where we solve an actual manufacturing problem step by step using the 8D methodology. Remember, quality isn't achieved by inspection alone. It's built through continuous improvement. Thanks for watching, and we'll see you in the next video. Keep learning with the Factory Insights.